Good morning, 1A. Today we are going to be reviewing Chapter 4, which was Designing Studies. So in this video, I'm going to be going through the cheat sheet that we have for Chapter 4, basically going through all the vocab that we talked about. Now, the great thing about Chapter 4 is there's not any calculations. So as long as you understand these terms, you should be able to get these questions right. And kind of like single these out when you're taking the AP test. It's kind of like the easier questions to do. Pretty much a guarantee that one of the free response questions are going to be dealing with designing studies. And then also you're probably going to see about 5 or 6 multiple choice questions that are about designing studies. So it's important that you really understand these concepts. And we've been talking about them all the way since second quarter, so hopefully you have a pretty good understanding of them by this point. So first we're going to talk about surveys and samples. All right, so remember, anytime we're taking a sample, we want our sample to model the population. The population is what we're trying to get a statistic for, what we're trying to find data for. So for example, if I wanted to see the percent of Cambridge students wearing t-shirts today, I would take a sample of 50 people. So that would be our sample. But the population is everybody at Cane Ridge. And my statistic, my data, we're using that to estimate what the parameter is, the actual number is for the entire population. So the entire population would be the entire student body at Cane Ridge. So most of the time when we're doing any type of survey, you're going to be doing a sample of the population because it's not going to be feasible to get data from every single person. Remember, we talked about how it's even hard to get data from every single person at Cane Ridge, let alone if you're dealing with all 8th graders or all 9th graders or just a larger population. So most of the time, we're just going to take a sample for our survey, but if we do have a survey where we take every single person in the population, that's called a census. Now, going down to our next section, dealing with bias. So bias is something that we've talked a lot about. So there's a lot of different ways that bias can come into the design of your study. So a couple different ways you could have bias in the way that your wording is if you're dealing with a survey. For example, if you're doing a popularity approval rating poll for President Trump, if you start off the question, due to President Trump's policies, thousands of children have been separated from their parents at the border of the U.S. and Mexico. That was the first part of your question. Then your next part of your question is, do you approve of President Trump? That's probably going to introduce some bias into your wording because you're saying something very negative about President Trump before you're asking the approval rating. So question bias is a way that you could introduce bias in the form of your question. And then there's a lot more subtle ways you can have bias in the way that you're sampling. So anytime you're doing a sample technique that's not representing the entire population, then that's going to introduce bias. So if I wanted to see what all the students at Cane Ridge thought and only sampled my statistics classes, that introduced bias because I'm only surveying mostly seniors and students that are in honors or AP class. So that's not going to be a good representation of the whole school. We're missing out on freshmen, sophomores, and students that aren't taking honors math classes. So you want to try to eliminate bias as well. So the main way we can do that in sampling, or if we're dealing with an experiment, is randomization. And that's why it's a condition for every single confidence interval, every single test that we're dealing with. You want to incorporate randomization in your sample or random assignment if you're dealing with an experiment. So now let's go on and talk about the different types of sampling. So remember, a convenient sample is when we have a sample that we just take that's convenient to us, right? So if I wanted to do a convenient sample and survey students at Cane Ridge, if I surveyed the first 50 students that walked into across in the hallway, then that would be a convenient sample. It's fast and easy, but the downside is you're going to be introducing bias most likely. There are types where you could have convenient sampling and the bias would not be there, or it'd be very, not really have that much of an influence, but it's not randomized, which is what we want. Voluntary response is where people are voluntarily responding to your survey, or your so you want to make sure if you're having a good design, you don't have voluntary response, because that can introduce lots of different types of bias that could affect your results. Now, in real life, a lot of times when you're dealing with surveys, it's going to be voluntary response because that's the easiest way to collect data, but just know that you have that bias. And that's one reason that a lot of political polls sometimes can be inaccurate, because political polls are essentially voluntary response, because people can't tell you who they're voting for. It's a voluntary thing. So that's why sometimes political polls cannot be 100% accurate. Next, we have a simple random sample. So this is a good design. It does take more time, but a simple random sample is where you give everybody in the population the same chance of being selected in the sample, and you select those people randomly. So the easiest way to do it is you number everybody in the give everybody in the population a number, and then you select how many people you need in your sample, that many numbers randomly. So if I want to do a sample of 50 students at Cane Ridge, I give everybody at Cane Ridge a number 1 through 1800, 1900, how many students we have, and then I use a random number generator or pick numbers out of the hat to select 50 numbers, and I use those corresponding names for the students I include in my sample. Now, if you're writing out a response on the free response question on your test, we want to say use a random number generator, or you could say put those numbers in a hat or names in a hat and pick 50. Okay? You just want to display, show how to implement that randomization. This random digit table, this is something that is probably not going to come up, so we're going to cross that part out. That's something that they have taken out of the test a couple of years ago, so you don't have to worry about that. Essentially, if you want to look it up online or in your textbook, it's just a way to select numbers randomly using a table, but they kind of took it out because nobody's ever going to use that in real life, because there's computer programs and calculators to do that. So again, choosing a simple random sample, you want to assign every individual in the population a number, and then use, it says here, table B, but you can use a random number generator or put all the numbers in a hat to select the numbers for your sample. So a stratified random sample, that is where we start by classifying the population into smaller groups of individuals called strata. So again, the example that we've talked about a lot, if I want to do that with Cane Ridge, I would have different strata for each grade level. So I split them up into all the freshmen, all the sophomores, all the juniors, all the seniors, and then complete a simple random sample within each of those groups to make sure I have equal representation from each of those groups. So if I wanted 50 students from each grade level, I would do a simple random sample for the freshmen, 50 simple random sample for the sophomores, juniors, and seniors, and put them together to get a combined sample of 200. So a stratified sample, that's where we split them up to a common characteristic, and then within those different strata, those different groups, we select a certain amount of people randomly. A cluster sample is where we classify people due to convenience into different groups. So a way we could do that at Cambridge is we label everybody according to their PLT class or their English class or their math class. So we have not as many numbers as if we had done that for the entire student body. We just have, let's say, 120 different PLT classes instead of dealing with 2,000 students. So we don't have to write out, it's a lot less numbers to write out and assign. So it makes it easier. And then we randomly select a certain number of those clusters, those groups to include in our sample. So let's say I wanted 60 students in my sample. I would randomly select 3 different PLT classes from school, include everybody from those classes in my sample. So once you randomly select the clusters, you have to include everybody in that cluster in your sample. So this one takes less time than a simple random sample or stratified, and it includes randomization, so that's kind of the benefit of that. But there is still some possibility for some bias to go in there because you are selecting people. Each cluster is not assigned, the people within each cluster is not random. So there is possibility for some bias that could be included. So again, we've talked about a little bit of this, some of this already, but some ways bias can be coming about in surveys or samples. Undercoverage is when some members of the population cannot be chosen in a sample. So for example, if I only surveyed my stats classes, freshmen and sophomores would be undercovered, and that would be an undercoverage bias. A non-response bias is when some individuals in the population can't be contacted. So if you did a survey wanted to do a survey for all U.S. adults and send it out via email, everybody's email address, then you're having a non-response from those adults that don't have an email address. And again, wording of questions can also be a strong bias as well, like we talked about earlier in the video.